Time travel and wormholes, concepts that sound like they belong in the realm of science fiction. But could they actually exist? Could we ever find a way to travel through time or take shortcuts across the universe? Einstein's theories of relativity suggest that time is not as fixed as we once thought. It bends, stretches, and even slows down under the right conditions. And if space and time are connected, could wormholes, shortcuts through space-time, allow us to journey across vast cosmic distances in the blink of an eye? In this video, we'll explore the science behind time travel, from the mysteries of time dilation to the mind-bending possibilities of wormholes. We'll dive into the challenges of traveling through these cosmic shortcuts and the dangers they might hold. Could the universe allow us to travel through time and space in ways we've only imagined? Or are wormholes just a beautiful mathematical curiosity? Time travel sounds like pure science fiction, but the laws of physics suggest it might not be entirely impossible. According to Albert Einstein's theory of relativity, time isn't a fixed constant, it's fluid and relative, influenced by speed and gravity. This concept is known as time dilation, and it's the first clue that time travel could, in theory, be possible. Einstein proposed that space and time are interconnected, forming a four-dimensional fabric called space-time. Massive objects like planets and stars warp this space-time, creating what we perceive as gravity. But this warping doesn't just bend space, it also bends time. This means that time passes more slowly in strong gravitational fields. The closer you are to a massive object, the slower time moves for you compared to someone far away. This phenomenon isn't just theoretical, it's been proven through experiments. In 1971, scientists used atomic clocks on airplanes to show that time actually moves slower for the clocks in flight compared to those on the ground. This is because the planes were moving at high speeds and at higher altitudes where the gravitational pull is weaker. The faster you move or the closer you are to a massive object, the slower time passes for you relative to a stationary observer. This is called relativistic time dilation, and it suggests that traveling at near-light speeds could allow someone to move forward in time. In theory, if you could travel at 99% of the speed of light, time would slow down so much for you that a year of travel could equal hundreds or even thousands of years passing on Earth. This concept, known as time dilation travel, would allow you to visit the future without aging at the same rate as everyone you left behind. But does this mean we could travel back in time? That's where things get more complicated. According to Einstein's equations, time travel to the past would require something far stranger, a bridge through space-time known as a wormhole. But before we explore that, let's look at how time dilation already affects our daily lives. Time dilation isn't just a theoretical concept, it's something we experience every day without even realizing it. In fact, the technology you're using right now relies on time dilation to work correctly. Take GPS satellites, for example. These satellites orbit the Earth at high speeds and at altitudes where the gravitational pull is weaker than on the ground. According to Einstein's theory of relativity, this causes time to move slightly faster for the satellites than it does for people on the surface. If this sounds confusing, consider this. The clocks on GPS satellites tick about 38 microseconds faster per day than clocks on Earth. That might not seem like much, but if left uncorrected, this tiny difference would result in navigational errors of up to 6 miles per day. To counteract this, the satellite systems are programmed to adjust for time dilation, ensuring accurate positioning on Earth. Without accounting for time dilation, modern navigation systems simply wouldn't work. But GPS satellites aren't the only proof of time dilation. Astronauts aboard the International Space Station also experience time at a slightly different rate. Traveling at 17,500 miles per hour around the Earth, astronauts are moving fast enough to experience a tiny but measurable time dilation effect. Over the course of a year in orbit, an astronaut will age about 0.01 seconds less than people on Earth. This means that when they return, they're technically a fraction of a second younger than everyone they left behind, a real-life example of time travel to the future, albeit on a very small scale. These effects, while tiny, are proof that time is not constant. The faster you move, or the weaker the gravitational pull, the slower time passes for you relative to someone in a different frame of reference. Time dilation is not just science fiction, it's a fundamental reality of our universe. But what if we could push this effect to the extreme? Could we use time dilation to travel centuries into the future without aging? And if moving forward in time is possible, could we also find a way to travel backward? That's where wormholes come into play. Hypothetical tunnels through space and time that could connect distant points in the universe. If time dilation shows that time is flexible, then wormholes take that concept to a whole new level. In theory, wormholes could allow us to travel vast cosmic distances or even move through time itself. But what exactly are they? A wormhole is a hypothetical tunnel through space and time. Imagine space-time as a two-dimensional sheet of paper. If you fold that paper so that 2 points touch, a wormhole would be like poking a hole between those points, creating a shortcut. Instead of traveling across the paper, you'd simply pass through the wormhole and instantly arrive at the other side. This idea comes from Einstein's general theory of relativity, which describes how massive objects warp space and time. In 1935, Albert Einstein and Nathan Rosen proposed the existence of Einstein-Rosen bridges, what we now call wormholes. These bridges could theoretically connect two distant points in space-time, creating a tunnel between them. But wormholes aren't just about traveling across space. If they exist, they could also allow for time travel. Because space and time are interconnected, moving through a wormhole could let you jump forward or backward in time. This would be like stepping through a doorway and emerging in the past or the future, bypassing the time that would normally pass in between. However, there's a catch. Wormholes are purely theoretical. No one has ever observed one, and their existence depends on extremely complex mathematics that pushes the boundaries of physics. If they do exist, they would likely be highly unstable and would collapse almost instantly. To keep a wormhole open, scientists believe you would need something called exotic matter, a hypothetical substance with negative energy density. This exotic matter would repel gravity, acting like an anti-gravity force to hold the wormhole open. Unfortunately, exotic matter has never been observed, and we don't even know if it's possible to create. Even if we could find or create exotic matter, traveling through a wormhole would come with its own set of challenges. Intense gravitational forces could tear apart anything entering the wormhole, and time itself might behave unpredictably. This has led some physicists to question whether wormholes could ever be stable enough for travel. Despite these challenges, wormholes remain one of the most fascinating possibilities in theoretical physics. If they exist, they could unlock the secrets of time travel, faster than light travel, and even parallel universes. But could we ever actually travel through them? Or are they just a mathematical curiosity that will remain forever beyond our reach? The idea of traveling through a wormhole sounds like something straight out of science fiction. A tunnel through space and time that could let you instantaneously cross galaxies or even visit the past or future. But could it actually be possible? In theory, wormholes could allow for faster than light travel by creating shortcuts through space-time. If you entered one end of a wormhole and exited the other, you could arrive at your destination faster than light traveling through normal space. This would make interstellar travel possible, allowing us to explore distant galaxies within a human lifetime. But before we start packing for a cosmic road trip, there are some major challenges to consider. The first problem is stability. Wormholes are believed to be extremely unstable, collapsing almost as soon as they form. According to Einstein's equations, the intense gravitational forces inside a wormhole would cause it to pinch shut faster than anything could pass through. To keep a wormhole open, physicists proposed the use of exotic matter, a type of matter with negative energy density. This exotic matter would counteract the wormhole's gravitational pull, preventing it from collapsing. But here's the catch. We've never observed exotic matter in the universe, and it's uncertain whether it even exists. Even if we could find exotic matter, traveling through a wormhole would come with another big risk: tidal forces. These are the same forces that cause ocean tides on Earth, but on a much larger and more dangerous scale. Gravitational forces near a wormhole would stretch and compress objects passing through, a process known as spaghettification. Anything entering the wormhole, including a spaceship or a human, could be torn apart at the atomic level. But let's imagine we somehow solve these problems and manage to travel through a wormhole. Would it be a one-way trip, or could we return? According to general relativity, if one end of the wormhole was moved at relativistic speeds, close to the speed of light, it would experience time dilation. This could create a time difference between the two ends of the wormhole, potentially allowing for time travel. This opens up some mind-bending possibilities. If you entered a wormhole in the present and exited the other end, where time had moved slower, you could arrive in the future. If the opposite happened, you could theoretically travel into the past. But this leads to another complication: time travel paradoxes. If wormholes can create shortcuts through time, they also create the potential for causal loops and contradictions, like the grandfather paradox. This is the idea that if you went back in time and prevented your grandparents from meeting, you would never be born. But then who traveled back in time to stop them? These paradoxes challenge our understanding of cause and effect, leading some physicists to suggest that wormholes may be restricted by cosmic laws that prevent time travel. Others believe that traveling through a wormhole could create a new timeline or parallel universe, avoiding paradoxes altogether. Despite all these challenges, the idea of wormhole travel continues to fascinate scientists and storytellers alike. Theoretically possible, but practically impossible, for now, wormholes remain in the realm of science fiction. We've explored how time isn't constant, how it can be stretched and bent by speed and gravity. We've imagined the possibilities of wormholes, shortcuts through space and time that could allow for interstellar travel, or even time travel. But we've also seen the challenges and dangers involved, from the need for exotic matter to the risk of spaghettification. Wormholes remain purely theoretical, but they remind us of the limitless possibilities the universe holds. Could we one day find a way to harness them, or are they destined to remain mysteries of mathematics and imagination? If wormholes existed, would you dare to travel through one? Join us next time as we continue to explore the mysteries of the universe